What's up YouTube? In this video you are going to learn how to use coroutines in Android and also how to use coroutine scopes and what dispatchers are. So we're going to use all of that stuff in order to make sure that our applications are going to be more stable and are using best practices, or at least we as developers are using best practices. So we are going to use the example that we built up in the previous two Android videos on this channel, and that was the video on retrofit as well as on MVVM. So if you haven't watched those two videos, definitely check them out if you want to really understand all of the other code that is going to be used in this video, because otherwise I believe it wouldn't make sense. Because the idea is to really optimize the code that we had before in order to now use coroutines instead of using the callback methods that we used before. This will make our code cleaner and also more efficient as well as more stable. So we're going to extend this application that we have built here, or revise it a little bit, and that was this retrofit example app where we load the Rick and Morty characters from an API and then display them in a recycler view. And if you think that that's a great idea, and if you like the video, then definitely hit that like button and also the subscribe button if you don't want to miss out on other Android related tutorials in the near future. So let's get started. Alright, so in order to explain the concept of coroutines properly, I'm going to use this real world example where we are loading data from an API and we're using retrofit in order to get the data from that API. So if you don't have the code and if you want to build this app yourself, definitely check out our retrofit video and also the MVVM video. This will really help you to understand what's going on in this project. Okay, so what we have here is, for example, our fun get characters, and it's going to get the characters which will be based on the page that we're looking at, and it will do that using our API service where it will then fetch the characters, which basically makes a call where it gets a response and gets the characters. So we are using an API call here, and this allows us to then, well, use all of the retrofit stuff here. You can see we're using get, and this then basically loads data from the internet. And this can take a little while, right? So this process is going to block the UI thread because it has been performed over a network call, and we don't want this to happen because that is what it would lead to a frozen UI screen. And that's basically why we are using a callback here, right? So here we're calling, and then when calling this method and using this fetch characters method, we are using a callback. So if we're going to our main view model, you can see that that's where we are fetching the character, and we are using this callback here, which basically already takes care of doing that in the background. So retrofit takes care of executing this code on the background thread. But we can make this function shorter and more readable with the use of coroutine. And this is also the best practice nowadays. So now let's modify this project to use coroutine. This is the third part of our series, and the previous two lessons where we covered retrofit and MVVM are basically the foundation for the code that we're using here. So to use coroutines and the built-in scopes, we need to add a couple of dependencies. So let's go over to our build.grail and make sure that we are adding the coroutine versions here first. So here coroutine 151 is going to be the one that I'm going to use, and then the coroutine scopes. Let's add those here as well to our dependencies. So I'm going to implement the coroutine core, coroutines Android, as well as the ViewModel KTX for the scope, as well as the lifecycle ViewModel and the lifecycle runtime. Once I've added that, let's sync it. And we're going to look into what ViewModel scope and lifecycle scope are in a second. Before we do that, however, after it has synced, let's go over to our API service, which is here in our API client class. This is where our API client object was created, and that's where we had our interface API service. So now I'm going to add a keyword which is important for coroutines, which is this suspend keyword. So this is the suspend keyword / modifier, and when you add that at the beginning of the function, then we remove the call interface from the return type. So here we can get rid of this call at the end, and we can just return a character response. Now, after we've done that, if we look at our repository, we will see that we get an error for our fetch characters. So here it says suspend function fetch characters should be called only from a coroutine or another suspend function. So you can only do that in a coroutine or in a suspend function. That means that here we also now need to add the suspend keyword. And now this error will disappear. So now to finally execute this function, we need a coroutine scope. And coroutines follow the principle of structured concurrency, which means that new coroutines can only be launched in a specific coroutine scope. So if you create a scope and don't clear it at the end of the operation, it can cause a memory leak, and well, you wouldn't want that. In Android, there is a built-in scope that can be used for specific classes, and let's look at that. So let's look at coroutines and those scopes in a little more details. So to summarize the features of coroutines, first of all, they are lightweight. This means that you can run many coroutines on a single thread due to the support of suspension. Then you have fewer memory leaks. By running a coroutine in a specific scope, you ensure that they do not leak as it terminates at the end of its scope. Then you have built-in cancellation support. So the launch option returns a job which can be used to cancel the running coroutine. And it is integrated into Jetpack. So many Jetpack libraries include support for coroutines, for example, Room and the Work Manager. So basically, if you want to develop for Android within 2021 and later, this is definitely going to be the way to go. Okay, so then let's look at coroutine scopes. So there are built-in scopes you can use to launch your coroutines. To finally execute this function, however, we need a coroutine scope. And coroutines follow the principle of structured concurrency, as I said, which means that new coroutines can only be launched in a specific coroutine scope. So if you create a scope and don't clear it at the end, you can run into memory leaks, and you want to avoid that. So let's look at the ViewModel scope. It can be used to launch a coroutine in a ViewModel class. It will automatically be cancelled once this ViewModel is cleared. And then you have the lifecycle scope, which is used to launch coroutines in the activity or the fragment, and is cancelled automatically when they are destroyed. So when the lifecycle is destroyed, which is good because then you are not running into memory leaks. And you can as well create a custom scope, but it is important that you attach it to a job and clear it when the execution is done. To create one in your activity, you create a global job variable, you create a coroutine scope and attach a job to it, and then you execute it, and finally you cancel the job when the activity is destroyed. Okay, so this is how you could potentially do it if you were to create your custom scope. So you're learning something about Android app development in this video, and maybe you want to learn a lot more about it. Then you can check out one of my 2 courses. So if you are a beginner Android developer, then I would highly recommend to check out my Android Masterclass course. There you will learn to build Android apps from scratch and you become a real Android developer. Or maybe you want to become a better Android developer because you are one already and you want to become a real pro. Then I would recommend to check out the Jetpack Masterclass, because there you will learn how to use Jetpack, which is a suite of frameworks that will make sure that you are a senior app developer. All right, so I would really recommend to check out those courses if you want to step up your app development skills very quickly. You can find a link in the description below, which will send you to the course with a huge discount. All right, so thanks a lot for checking out those courses. This really helps us out and this enables us to create these videos. Either way, I wish you a nice journey to becoming a great app developer. And now let's get back to the video. All right, so now let's go over to our main view model and customize this code a little bit, because you can see it's already quite unhappy because we made the changes with the coroutine setup, right? So we have this client repository get characters. So this by itself, this fetch character method has to be overwritten. So this part here, we're not going to need that anymore. And then the enqueuing. So basically we're going to instead use our view model scope. You can see it's available there directly, and we can launch it. So you can launch it and then say what code you want to run inside of it. Because what we're doing could potentially run into an error, we will use try and catch here. So what is it that we want to try? Well, we want to try to get all the characters. So here I'm just going to set up my client using the repository.getCharacters on the first page. So here this was a string that we required to add there. And then I can just go ahead and use my characters live data in order to post the data. So this will be what we're trying to do here. And actually, let me get rid of all of that except for this part here. Let me cut that out and get rid of this client enqueue. And here, this will be in the catch clause. So here, where we are getting the exception. And I'm just going to put that code in here. And here it wouldn't be a T message, but the E message, and the E message to a string will do the trick here. Now you see that this response body result isn't very happy because, well, we're not using the response body anymore. We are instead using the client. So this one that we have set up here. So you see all of the code that we had before basically replaced with this little code here. So this was basically the code that we had before, except for this view scope and stuff. And now we can get rid of all of that with just that. And not only was it less code, but it's also the best practice way. So in the try, we execute the get characters method here, and we basically get the characters from the page, from the first page, which means Brick and Morty and all of the good guys. And then in the catch block, we just execute what should happen when we get an error. So here we know we are successful, and here we have the error. And before we launch the view model scope, we just say, okay, the current state is going to be loading. So we're loading data when we're fetching the characters. So really super optimized code here. And now let's have a look at dispatchers. So a dispatcher is used to specify which thread a coroutine should run on. So looking at the example that we have here, we haven't specified any particular dispatchers. So you don't necessarily need to specify one because coroutines are lightweight and run safely on the main thread, but there would be processes that you would like to be more precise and make it run on a different thread. So let's say you want to make sure that the coroutines process that we're running here should in fact run on the background thread, then you could use dispatchers. Okay, because basically what we're doing here is really we are running something that could potentially take longer but on the main thread, but using coroutines, and coroutines are a smart way in the background that know how to handle it. So they will only run or use resources that aren't required, for example, to make sure that the screen is going to be stable, which means the view will be stable and it doesn't freeze or anything. So let's look at the dispatchers that we have available. So we have dispatchers.io, which is useful for network calls or local databases. Then dispatchers.main, which is useful for updating the UI. And finally, dispatchers.default, which is useful for CPU intensive tasks. So for now, let's see on which thread our operation is running. And as I told you, it's going to run on the main thread. So here inside of my launch, just before the try, I'm just going to say, okay, log.mainViewModel. Just let me know the name of the current thread that you're running on. So let's run this application real quick and go over to our logcat once it is loaded. All right, so it's running, and now let me search for main view model, and you see it runs on the main thread. Okay, so the thread name that this scope, this view model scope, is running on, so our coroutine, which basically does all of this loading of data with the API stuff, is running on the main thread. So that is something that Android handles itself. So we just gave it the power to do it how the system believes is the most efficient way by using coroutines. But now let's say we wanted to specifically use a particular thread. Then we could go ahead and add that to the launch method here. So here you can pass a parameter to its launch. You could say that you want to use dispatchers.io, for example. And it's written like this, dispatchers.io. It's inside of Kotlin X Coroutines, this class. So you will find that it is in your imports here. As you see, we're not using all of this retrofit stuff anymore here. We can get rid of that. And now let's check out what thread we are running on this time. So let me run it once again and check out the main view model here, and you see default dispatcher worker 1. So now is running on a background thread. So we have switched to the workers thread, also known as the background thread. And this was done in the worker 1, but it could have also been done in the worker 2, for example, if there was more to handle. Okay, so that is basically how you can use coroutines using coroutine scopes and, well, making sure that your application is more stable and runs more stably. All right, so that's it for this 3-parter. I hope you enjoyed it. Now you know how to use Retrofit, how to use MVVM, and also how to use coroutines. I hope you enjoyed it, and if you did, then please hit that like button. It really helps us out, and also the subscribe button while you're at it, because we're uploading more Android related stuff on this channel. So see you in the next video.